Generative AI is the technology behind the wave of new online tools used by millions around the world. Some can answer queries on a huge range of topics in conversational language. Others can generate realistic-looking photographs from short text prompts. But even industry experts are concerned that the technology may be going too far, too fast. And lots about the technology remains opaque. The Economist science editor Alok is joined by deputy editor Tom Standage, science correspondent Abby Bertics, and global business and economics correspondent Arjun Ramani to discuss this new era of AI.
Abby, you've written for The Economist and also talked on the Babbage podcast about large language models and how they work. And what people might not know about you is you're a computer scientist yourself, who's now a journalist, and so you're perfect to help us understand how these things work. Just if you can explain in just a few minutes, how does a chatbot, when you put in a question into a chatbot, how does it come up with a response?
Well, I can give you a really short answer on what these large language models are, and they're statistical behemoths who have one job, and that's to predict the next word. A slightly less condensed version, there are 4 main steps that these large language models go through. First, like when the user types in their query, it's in words that humans understand. Machines don't understand these words, so the first step is to convert these words into numbers. And it first does this by chunking the large string of text into these things called tokens. Often these are words, they could be parts of words, but each token in like GPT-3, for instance, corresponds with a number. And once they're converted into numbers, that's finally something that the large language model can understand. And so once we've got the token IDs, the numbers, the second step is to put them into kind of a meaning space. So if you have just random numbers, that means nothing. But the next step is to kind of give them definitions so the words have some sort of meaning. And once we have them in this meaning space, this is like the main part of the large language model. And you've probably heard about it a little bit. It's called attention. And the goal of attention is to, rather than just looking at all of the words independently and all of their definitions independently, you're trying to find connections and associations between the words. So GPT-3 has about like 100 different types of these attention mechanisms. And each attention mechanism is trying to figure out, okay, which words are connected together and how much are they connected and why. And after it's gone through all of this attention stuff, associations between words, between concepts, between ideas, then it kind of creates this probability distribution. Which word is most likely to go next? It chooses a word from that distribution, and then it does the whole process all over again, over and over until it kind of generates your answer that you see in the chat response.
And so the final part of that, which basically is a way of trying to work out a probability for each word that might come next. Obviously, in its dictionary, it's got thousands of words. It gives a probability for each one. But the crucial thing here is that it doesn't necessarily pick the word or the chunk that's the most probable, right?
Yeah, that's absolutely right. If it did, you would get the same response every time you typed in your prompt. But if you've tried it, that's not the case. There's kind of this like randomness to it. So rather than always taking the greedy approach, which would be choosing the word with the highest probability, it samples from it. And these language models actually have this parameter called temperature, which kind of controls how random and spontaneous and creative it's allowed to be. So different use cases would have different temperatures. But you're right that it samples differently depending on what you want.
And that's what makes them interesting, because the results are not always predictable. And we'll come to this, there are emergent behaviors and properties that make these systems feel very intelligent when you're using them. Okay, Tom, The Economist has written about AI many, many times in its various forms over the years. And probably most of those articles have been written by you, to be honest. But it recently made the cover of the paper again. What's changed since the last time we were really interested in it that's made AI much better than perhaps it used to be?
Yes, good question. And I was very pleased to say that, we put AI on the cover. Literally, that was all we had on the cover, the letters A and I. and I'm another computer scientist turned journalist. I should confess. Basically, two things have changed. One is that, I mean, Abby mentioned there in quite a lot of detail the attention mechanisms and this new attention mechanism. So we've experimented at The Economist a few years ago in about 20. Must have been 16 or 17. At the time, the attention mechanism that everyone used was called LSTM, and it wasn't very good. And what happened in 2017 was that some researchers at Google came up with a better attention mechanism called the transformer, and that's what the T in GPT stands for. And so essentially that made these systems a lot better. They could sort of come up with longer pieces of coherent output, whether that's text or computer code or whatever. So there was a technical breakthrough, and that took a while to ripple through the community, and then people started making bigger and bigger models. So that's one of the things that changed. But the other thing that changed is that this technology became much more visible. So it was possible with those older models, so GPT-3, for example, which was the first really capable large language model. I hooked it up to be a chatbot in 2019 and interviewed it about what might happen in 2020 for our annual The World Ahead. And to make it work as a chatbot, you had to sort of hack around a bit. Of course, what happened last year is that a much more capable model, GPT 3.5, was launched as ChatGPT, literally as a chatbot, which anyone could sign up for. And once you got to the front of the waiting list, you could go and talk to it. And you'll have heard these numbers that 100 million people tried it within the first 2 months, and that's reckoned to be the fastest adoption of a consumer technology in history. So the thing that really changed is that suddenly there was a way that anyone could use this technology, and they came up with all sorts of amazing uses for it and asked it to do all sorts of extraordinary things. And that was what really put it on the map. So it's really that combination of the technology got better and has got better in the last 5 or 6 years, but really the visibility and the accessibility of the technology, that's what's really changed just in the past few months with ChatGPT in particular. And of course, that's led the rivals to OpenAI, the maker of ChatGPT, to launch their own chatbots as well. We've just had a whole load of announcements this week from Google that's putting them in everything. Microsoft wants to put them in everything and so on. So this is suddenly a technology that is at your fingertips if you want to use it.
That perfectly sets me up to ask Arjun then. We've heard about GPT 3.5 and GPT-4 recently from OpenAI, which seems to be the company that everyone's talking about. And Google this week has announced that it's going to put its version of a large language model into every single one of its apps. Can you give us a bit of a view of the landscape? Who's making these models? Where are they at? Who's ahead?
Absolutely, Alex. So you mentioned the two key players. OpenAI, who is kind of allied with Microsoft, and Google, which has kind of its own a lab of its own called DeepMind. And I actually think that structure is a little bit revealing, right? With AI, you need a few things. You need really, really highly talented researchers who are capable of making breakthroughs, who can move fast, experiment, but you also need lots of resources. These models, they cost a lot to train. In fact, GPT-3 cost somewhere around $4 to $5 million. And GPT-4 actually costs north of $100 million, right? So you're talking about big sums here, and you need a lot of computer power and data as well. And so that's why you kind of have these big tech companies allied with smaller labs that are kind of leading the race, if you will. Now, of course, as you alluded to, there are a lot of companies, and as Tom mentioned, there are a lot of companies that are getting into this now, besides OpenAI and Google. There's another startup called Anthropic, which was, created a chatbot called Claude that's actually, pretty good. It's just as good as the first version of ChatGPT. And in fact, they were started by a lot of the early employees from OpenAI. So, that tells you the importance of having that kind of insider knowledge. Of course, if you go across the world to China, they're also, very relevant in this AI race. Baidu, which is the search giant of China, kind of the analog to Google, has launched a bot called Ernie. And it's estimated to be approximately as good as GPT-3. Most people think they're maybe 2 to 3 years behind the bleeding edge models in the US. So and more startups are getting started all the time working on these types of things. I mean, Tom actually had a great piece in this week's paper looking at open source models. It actually can be really cheap to take a model that has been released to the internet. For example, Meta, the creator of Facebook, they have released an open source model called Llama, and you can you can download the weights, you can download that model, and you can adapt it. You can do what's called fine tuning to your own application, and that's pretty cheap. It'll cost maybe $1,000, and you can get performance that's as good as ChatGPT, the first version on a lot of different tasks. So the landscape here is quite competitive. There are a lot of players, and it'll be interesting to see how it moves forward.
Yeah, and the weights you mentioned there, they're the numbers stored within a particular model that allows it to make answers that are interesting and accurate, basically. This is where the gold is, essentially. Tom, we've written in the past, and it's well known that the cost of computing has been going down a lot. The number of transistors you can get onto a chip, Moore's law, it has been in effect for a long time, and things like that. That means the computing just gets faster and better and cheaper all the time. We've seen generative AI appear on the scene very recently, and it's got better and better very quickly. Is this just the start of an exponential increase? Do we expect Moore's law or something equivalent to happen there too?
Well, it's interesting because just in the past few months, people have started to ask questions about whether bigger is always better with these large language models. Some of them have, there's a Google Palm model that has 540 billion parameters, which is the number of weights inside the model. And if you read the Google memo that everyone has been talking about in the past couple of weeks, one of the things it points out is that the growing recognition that a lot of these very big models seem to have been trained for not very long, but are very big. And it turns out that you can get good results with a smaller model that you train more intensively. And Sam Altman, the head of OpenAI, recently said that he thinks that this kind of race to make these models just bigger and bigger has come to an end, and that people have realized that actually you need to make them smarter, you need to train them more intensively, train them in new ways, train them on more specialist data sets, do fine-tuning of them, which is a sort of process where you can make a general language model a specialist in a particular task. So I think the kind of bigger is better. It's sometimes called the chinchilla trap, because the sort of relationship between scale and power was, particularly, there was a model called Chinchilla where people sort of analyzed this to sort of figure out what was going on. And you don't want to just say, let's make it bigger, because the cost of training these models is very, very expensive. It's tens of millions of dollars. It can take months. And if it turns out that you can get better results with a smaller model, more intensive training, or by fine tuning a model, which does seem to be the case, then that's going to mean that this is a more accessible technology. It costs less to train it, and that means that we're going to get faster progress at a lower cost. So this is very much up in the air, the sort of economics of training these models. But I think the bigger is better era may be coming to an end.
But also, I suppose that given that the current generation of models are trained on pretty much the whole internet, or at least a good subset of it, then at some point you run out of data, you run out of the number of chips. There are physical limits in the world that will mean that you just can't make them bigger. So cleverer ideas have to come along to make them better, essentially, which is what we're alluding to. Now, let's talk about some of the positives of generative AI before we start to talk about some of the things that might concern us. And Abby, I think that this is one for you. You just helped us to understand how these models work. In your view, what are some of the strengths and weaknesses of the kinds of things that they produce? What tasks does a large language model do well, and what do you think that they struggle with?
Well, I think one of the huge strengths of these large language models is that they're able to kind of crunch and churn through such scads of unlabeled data. So normally, in the past with AI, you always needed your thing and a label. So that required humans to kind of go through and label them. But these large language models, you chuck in the internet and you get out of it a blurry picture that is basically taken of hundreds of billions of words. And it honestly just seems to do well. I think a lot of people are still kind of baffled why it's doing so well at so many tasks. It generates convincing text. It's very good at pattern matching. Style transfer is one of the other things.
Go ahead. So what's a style transfer?
That's where you can be write a love letter in the style of a pirate from the 14th century that has an Irish accent but is from the Bahamas. I don't know, that was completely random. But you ask it to do something, and you ask it to write it in a certain way or in a certain funny rhythm, or you ask it to write a sonnet, you ask it to write a computer science textbook as Shakespeare would have, for example. And then it's also pretty good at passing standardized tests, it seems. Like it passed the US medical licensing exam, it's passed some legal tests, basically very good at kind of text things. In terms of weaknesses, I think there are two main ones, and they're kind of around the same thing. One of them is the lack of transparency. Like it's kind of a black box. You can have access to kind of what's going inside the attention weights, what the weights that you were talking about earlier, Alec, what those values are, but they don't mean a lot to us. There's over 100 billion of these weights, and that's very, very complex and hard for us to understand in what they're doing. And so, I think the main weakness is that it's such a complex system and we don't really understand it fully.
And especially at the point where we're trying to use them for critical tasks, medicine or anything else, you kind of need to understand how the answers and decisions are being made within the system, which has always been an issue with deep learning, this new form of AI, which is we often can't explain how the AI system actually comes up with its answers. We have a question from a subscriber, Hoshi, and Arjun, I think this is one for you. How can AI be used by businesses? Can it speed up product development? Can it interface with customers? Can it generate marketing materials? Can it replace complex financial systems like SAP or Oracle? What do you think?
Yeah, it's a great question, and lots of businesses are already adopting it. Maybe let's look at some of the data, right? So there's a recent study done by Eric Brynjolfsson at Stanford and a few co-authors, and they found that for call center operators and the production of marketing copy, you actually got 15% more productive when you were using ChatGPT. They kind of split these various people into two groups. And it turned out that the people who benefited most in these businesses were those who were least skilled beforehand. So it seems like these chatbots can actually help people who are maybe not as good at producing, marketing copy or working in a call center. They get helped more. And so I think those are examples of some tasks that businesses might use these models for. And there's lots more, right? And the general thing that these models are really good for is ingesting information and then producing output, producing information response. And so you can think of all the creative industries, all the knowledge producing industries, all the industries that require that type of process could use it. Now, we shouldn't overhype it. So, the question mentioned, Oracle and, internal company data management and so forth. And I've actually talked to some businesses who are trying to do this, and they're running into a few roadblocks. One of them is how exactly do you get the language model to kind of interact with, the massive amounts of data that a company has. And it requires a lot of specialist knowledge. You can't just take ChatGPT and immediately, insert all of a company's databases and expect it to work. You require, a consulting team, or you require, some engineers from a top firm to come and help you do that. And so that's one of the reasons why it takes a long time for these technologies to penetrate. The other kind of limitation is around reliability. So for things like responding to a customer service call, if your response is not necessarily precise, maybe that's fine. You have some kind of tolerance for mistakes. But if you have a high stakes process going on inside a company, for example, payroll, you can't really automate that type of stuff easily because your tolerance for mistakes is much less. And so that's why the reliability of the models need to be improved, I think, before they start automating huge amounts of processes in businesses. But I mean, there's a huge amount of economic activity, I think, that'll get affected by this. I mean, the paper put out by some economists at OpenAI that said that around 20% of the U.S. workforce could have around 50% of their tasks affected by generative AI in the next few years, right? So a lot of tasks that we do on a day-to-day basis could be helped by these models over the long term.
Yeah, 50% will be affected, but it's still unclear in which direction. Clearly, it's not going to be that there's going to be a jobs apocalypse, which we had a piece about in this week's paper. Technology, generally speaking, people get worried about jobs being lost, but then people find other jobs or there are new industries created as a result. I think that's the stage where it seems to be at with generative AIs. Tom, before we started this call, you told us about how you were using generative AIs in your in your world. I just wonder, Tell us a bit about that, first of all, which I found really interesting. But also, do you think that AI technology now is living up to the sort of the potential and the kind of excitement that we've always kind of been writing about, but it's never quite managed?
Yeah, what's funny about AI is for a long time. So I went to university in the late 80s to study AI. I wanted to build AIs because I'd read a lot of science fiction, and it didn't work. That was the AI winter, just beginning in the early 90s. And the approach that was being used to AI in the 80s, the symbolic approach, didn't work and had failed. And the funny thing is that, for the following 20, 30 years, basically, AI was something that people laughed about. Well, it's following 20 years, the 90s and the 2000s. It was a technology that didn't work. And now things have changed and people are worried that it works too well. So that's a kind of high-class problem to have, I think, that it is living up to the hype. And in fact, that people are kind of worried about just how quickly it's getting better. But yes, I would like to add to Arjun's list of things you can do with this a really important one, I think, which is coding. So I've been a sort of journalist coder since the start. My first job as a journalist was at The Guardian, where I also built The Guardian's first website. And so the kind of journalist part of my brain doesn't find this technology actually that useful, and I wouldn't want to use the output of one of these systems in an Economist article unless it was labelled as such. And we've done this a few times. We've written articles about AI where we've said at the end that here's the final paragraph as generated by one of these systems. But if your job is to find out new facts, that's actually not something that these systems are really in a good position to do. And I was talking to people within the Foreign Office, the British government, the other day, and also they were saying, what's the impact of this? And I was saying, look, our job, whether we work in government or the intelligence services or journalism, is to find new facts. And they've got to be right. You really don't want to just take any old stuff coming out of one of these systems. So I think if as Arjun points out, if the accuracy matters, then these systems are maybe not so great. The great thing about writing code with these systems, and I do still write some code, is that if the code is slightly wrong, you find out straight away because either the interpreter or the compiler chokes on it, or the output of the code isn't quite what you were expecting. So you have this very tight feedback loop. And if it's slightly wrong, you find out pretty quickly. And there are other areas where not. If you're writing a children's story or something, maybe you might get some ideas from one of these systems because it's not about facts, it's not about accuracy. So I think that's I'm sure these systems will get more accurate and will get more up to date and that sort of thing. But at the moment, I think one of the big opportunities is writing code, and I also think that one of the big things that these things are bad at is finding out new facts. They're just not built to do that. They're built to generate answers based on based on stuff they've read on the internet, often from like more than a year ago.
And it's this idea of writing small bits of code that can help you just manage your workflow better, or with the diffusion models that can create pictures from a few text prompts. You being able to produce a drawing or an image when you're not yourself an artist, there's a little bit of liberation attached to that, isn't there? I mean, there are also commercial aspects and create copyright issues, all of those things. We shouldn't ignore that. But the idea that you could just create something quickly without having those skills necessarily is quite liberating and creative, and unlocking of creativity, actually.
It is, but I think there are illustrators who are worried about their livelihoods as a result, and also say that these systems are very good at imitating their style. So there are benefits, but there are also some difficult questions raised by this, and I'm sure we're going to be litigating this for the next few years.
Well, let's start talking about some of the negatives of generative AI, and it's worth saying here that there are lots of positives, and I don't think that we are necessarily thinking this is something that's going to be terrible for everybody. It's worth looking at both sides of this, all sides of this, and I think that people are concerned about existential risks and so on, but there are many other problems that might result from these sorts of technologies. Arjun, you wrote a long piece for the science section recently, all about harms and risks. Who do you think has the most to lose from widespread use of generative AI, and how can we head off some of these problems?
Yeah, it's a great question, and I think as you mentioned, there's a spectrum of risks here. I think the place to start is with the kind of more quotidian ones that we're familiar familiar with from the internet and social media, that being things like misinformation, hacking, impersonation, and so forth. We're familiar with these problems, but I think generative models potentially worsen them because it makes it less costly for anyone to, write a very sophisticated sounding phishing email to trick someone else into doing something. I've already heard of stories of people being scammed, and they suspect the person who was scamming them probably was using one of these tools to help them write, and that might grow. You could imagine, and Tom was mentioning the importance of how useful these models are for coding, and as a trained computer scientist myself, I've also found it extremely useful for getting onboarded into a new task or a new language that I didn't know beforehand. And I think you could imagine bad actors using these models to, for example, hack into websites, steal data, so on and so forth. So I think that's the place to start. I think as these models grow more and more powerful, I think the nature of the risks change. And I think there's a risk some people have. Eventually these models are going to outwit humans. Eventually they're going to learn how to self-improve. We're very, very far away from that. But then you open up a whole nother can of risks. And I think that at the core of all of these issues is this idea of being able to, I guess, understand what's going on under the hood. So this idea in machine learning of interpretability. Can you understand what the weights are actually doing, right? And as a result, can you point to a specific portion of a model and say, okay, this is the portion of the model that has gone wrong, or that is letting the model produce harmful or wrong outputs? And if you can create that, a mapping between components inside the model and potentially harmful outputs, then they become much, much easier to kind of make safer. We can't really do that yet, so we rely on other techniques. And the most common one that OpenAI has been using to make sure their models are nice to humans and don't say mean things is what's called reinforcement learning from human feedback. And the basic way that works is you feed a model prompts, and then you grade those prompts. You give it feedback. You tell it, hey, this was good. You give it a thumbs up, or you give it a thumbs up and say this is not so good. And the model gets updated based on that feedback. It's a reasonably effective method. It's one of the reasons why, ChatGPT is no longer, going off the rails. But it's potentially incomplete, right? It's possible to jailbreak or hack these models and get around them with creative prompts, which people do all the time. So, it's a work in progress.
Yeah, and creative prompts is sort of an art form in itself, and you can imagine that there's going to be plenty of people who do this just for fun to see how they can break these systems. Abby, as somebody who understands how these systems work and produce what they produce, how concerned do you get with any of this in terms of potential harms? When you hear about all the concern that people have in the world, it's a technology that they don't understand, but does understanding it more give you a sort of a clearer sense that it's not as bad as they think, or do you know something that perhaps investors are not concerned about enough?
Well, I'm not super concerned that these models, as they stand, are just gonna, get consciousness and become general intelligence and take over the world. It seems to me like the way that these models are formed, like the statistical relationships they have, the data that they are trained on, the objectives that they are optimized for, do not lead down that path. Whether there's actual harm, that's another question, because as it currently stands, these models can be used for tasks and by humans to do things that will cause harm. There's biases latent in these models, right? Like these models were trained on the internet, and the internet was there's a lot of information on there created by humans, and humans have bias. So one huge risk of these models is just to kind of perpetuate bias moving forward. But I think it's way more important to focus on like the harms that are present now than to kind of speculate as to what may or may not happen in a science fiction version of the future.
So you mean world-destroying AIs, essentially. Focus on what we know might happen and what we can do something about, rather than the AIs turning us all into paperclips or something.
Yeah, I think there's a ton of work to be done on regulation now, on interpretability, on explainability, and it's worth focusing efforts there where we can have a concrete impact rather than kind of freaking out too much about a very, very, very small risk that it's not even certain that it's possible.
Yeah, I was just going to add that there was a really interesting factoid we put in our cover that week on how researchers think about these existential risks, and so there was a survey done by a team at the Chicago Federal Reserve and University of Pennsylvania, run by Phil Tetlock, who's the author of a book called Super Forecasting, and basically they found that AI researchers rated the likelihood of an existential catastrophe by the year 2100 caused by AI at around 4%. But then when you ask trained forecasters who are known to have been trained to avoid cognitive biases, they understand the differences between small probabilities. Perhaps they don't suffer the same biases as other experts. They rate that risk an order of magnitude less, around 0.4%. So I think that's kind of an interesting factoid that a lot of people within this field, of course we should take what they're saying seriously, but perhaps they are working on this problem precisely because they think it's the most important one.
Well, the idea that experts are not the best at forecasting the problems in their own field is also fascinating, which I'm sure we'll come back to. We've set up the conversation now about how to deal with these potential problems. And I think regulation is something that the economy has been thinking about. Tom, you've written on this. We're starting to see regulators take an interest in LLMs. The FTC in America, the Competition and Markets Authority in the UK, they're all looking into the technology, which is a strange thing because technology has generally never been regulated very much. Now, I just wonder if you can help answer a question with two subscribers, Anshita and Chanpreet. They're both asking, how are different countries planning to regulate AI?
Yeah, it's a good question, and there's basically a spectrum of answers. So at sort of one end of the spectrum, you've got a laissez-faire approach is being taken by Britain and America, and they're starting to talk about how we might do this. But certainly the British government, its sort of initial thoughts on this say that we don't think we need a new agency to do this. We may not even need any new laws. We think that we can bring existing laws to apply to this technology. So that's sort of one end of the spectrum, and the British government is quite open about the fact that it's trying to attract investment to Britain, and it wants Britain to be an AI superpower and all this sort of thing. So that may be sort of causing it to lean in the direction of a hands-off sort of kind of light touch approach. Then you have the EU, which is saying, no, we need new laws for this. Not necessarily a new regulator, because it's up to individual countries to apply the rules, but this is a new important technology, and in the same way that we have technologies that we regulate in other areas like medicines and cars and aeroplanes, maybe we should be regulating this too. The difficulty is that the EU is trying to sort of imagine all the ways that AI can be used and all the ways it might go wrong, and impose sort of different degrees of requirements on companies depending on the level of risk. And that's a very moving target. I mean, they keep having to rewrite this law. They must be rewriting it every day, in fact. The version of it they put out last year didn't have anything on generative AI because it was pre-ChatGPT. So that's really difficult. But that's the position that they're taking, that we do need new laws. Some people go further than that and say, actually, we do need a new regulator, like you have the FDA for drugs in America, and the FAA for airplanes and so forth. And many countries have specific regulators for specific things. A lot of people have called for a sort of FDA for AI. Some have gone further than that and say, actually, what we need is a sort of IAEA, the body that goes around inspecting nuclear sites. For AI. In other words, we need an international treaty, something like the Non-Proliferation Treaty, in order to control the access to this technology. It's hard to see how that will be enforced, but there are people, making that argument. And then another interesting country in all of this is China, and China has, in effect, got a cyber regulator, and it says if you want to release products that use these large language models, you have to register them with the cyber regulator, and they also have to meet certain standards on essentially how socialist their output is. So it sounds as though the Chinese concern about regulating these things is mainly political rather than sort of accuracy or anything like that. Although I think they also say that they have to be accurate. So there's a big spread of approaches being taken by different governments, and none of these laws have really been put into force yet, and so we can't really tell which of them is more appropriate. But I think the analogy with previous technologies like cars and airplanes, I mean, cars, basically had no regulation at all when they first appeared a century ago, or a bit more than a century ago. There were no driver's licenses, there were no traffic lights, and lots of people were killed on the roads. And it was only in the 1920s that there was an outcry and regulation was subsequently introduced. So we're in the sort of pre-1920s phase for AI right now, where there is pretty much no regulation yet, but there is definitely regulation coming down the track of various forms.
And just to wind that up, I mean, what do you think? I mean, you wrote a leader for us on this. Where do you think the most sensible place to be is in that massive spectrum you described?
My view is that we need to be somewhere in between the UK and the EU position, and this may be where the UK and the US actually end up, which is I think we do need new regulations of some kind. I don't think you can just say we can make existing rules work here. I wouldn't go as far as saying we need an FDA for AI. It may be that existing regulatory bodies can, be responsible for this. It really depends where the biggest applications emerge are, I think, and what the biggest risks are, what the biggest problems are. So I'm sort of in favour of light regulation and some new laws now, but with the option to sort of turn up the volume on regulation later, depending on what happens. I think the main thing is that policymakers, lawmakers need to get their heads around this technology. I've been talking to people about it on both sides of the Atlantic, and there are people putting together. They want to essentially raise the understanding of this among the policymaking classes, and they're saying, who should we talk to, what should we be talking about, and that sort of thing. So I think we need to start from there, otherwise we're going to get bad laws. We've had various kind of quite misguided attempts to regulate the internet over the years, and this is, if we're not careful, we're going to get the same sorts of problems again here.
Now, just before we take more of your questions, I'd like to point you towards a piece from one of our colleagues in Economist Films that looks at how chatbots will change how we use the internet. The QR code on the screen now should take you straight there. Now, let's carry on with some more questions on AI from our audience. There are loads of them coming in. This one is from a subscriber called John, who talks about self-coding AIs. Okay, so when AI starts to write code, bypassing the high-level compilers that humans use and straight to machine executable code, will we have any way of knowing what's going on inside that program? Is that when humans will lose control over AI? I feel like we might have covered a little bit of this, but Tom, you're the code writer with the AIs now. What do you make of that question? Do you think that the fact is...
I mean, we're not getting AIs to write machine code yet, so they are writing high-level languages, and then we're running them through compilers. And so, yeah, I don't know. I mean, machine code is very unforgiving. If you get anything wrong, the computer will crash. So yeah, I don't see that happening. And this idea of sort of self-modifying AIs improving themselves, and the sort of the intelligence explosion, I've always thought was quite implausible, because it sort of assumes that these systems have unlimited access to electricity and computing power and money, basically, because you have to pay for cloud capacity. So I'm not so worried about that, and I don't think sort of this idea that we're going to let these systems modify themselves and upgrade themselves and then we'll take them by surprise. That doesn't strike me as a very plausible argument on the basis of what computer scientists would call computational complexity. These things, the bigger you make them, the more complicated they make them, the more complicated it is to build them, and the longer it takes. So the idea that you could have this series of steps where every step takes less time than the previous one to make a cleverer machine seems implausible on its face to me.
Arjun, I remember reading in your piece about potential harms that one of the breaks towards AIs getting super intelligent all by themselves is scientific research. They need to improve their own algorithms. If you tell that algorithm to improve itself, at some point it's going to have to do experiments in the real world, and the grubby humans are going to have to do something along the path. So are you worried about code writing computers becoming super intelligent in some way?
It's a good question. So I think I'm pretty similar to Tom on this one. I find it unrealistic that we can automate the full process. I do think we can use AIs to help with the process of AI research. In fact, OpenAI is already doing this, using GPT-4 to learn how GPT-2 is working under the hood, which could perhaps lead to advances in our future capabilities, and you can imagine that happening with code. But there's a close connection between training these big models and what's going on in the physical world, as Tom mentioned, right? So when you want to train even bigger models, you have to find out ways to optimize how you run your computer power over different chips. You have to potentially get more advanced chips. You have to change the layout of the circuitry and so on and so forth. So there's lots of things you have to do in the real world that humans have to be involved in. And then so there's some interesting research in the economics of innovation that talks about how if you want to get what we called an intelligence explosion, or if you want to get exponentially increasing rates of economic growth in any given domain, you need to automate the entire process. If you've only automated 90% of it or 99% of it, that doesn't get you nearly the same effect, because the slowest part of the process, which is maybe probably the human, acts as what's called a rate determining step. So we'll end up slowing things down. So I think that's probably what is likely to happen in my mind, where we use AIs to help us with research, which frankly we are already doing, but it still is not able to get 100% of the way there. So ultimately, the pace of progress continues as it has been.
So they would have become super intelligent and turned us into paperclips if it wasn't for those pesky humans getting in the way of making them more intelligent.
If we were as fast as humans, then I think it would.
Yeah, exactly.
The world would be very different.
The flip side of that, though, is good news. And if you look at the history of automation, it's always been the case that when machines are able to automate some tasks in your job, the rate limiting step becomes the bits done by the human, and those bits, those processes, then become more valuable. And we saw this with weaving, for example, where weaving machines meant that individual weavers could produce a lot more cloth. That didn't mean that most weavers lost their jobs. It meant that knowing how to operate those machines became a more valuable skill. The output of cloth went up, and the price went down, and more people got to buy stuff made of cloth. This is what we're seeing here in this case as well, where I think those people who know how to work with these systems in order to be more productive, those are the skills you want, the ones that complement these machines.
Abby, question for you from Mark. Will LLMs inevitably favor the English-speaking world to the disadvantage of those using languages with different linguistic structure and or smaller training sets? I want you to bring in your linguistic expertise here.
I think this is a really interesting question. One of the things that transformers and these large language models are actually quite good at, like kind of their initial goal was to translate, whether that's from English to another language or between other languages. So they're actually quite good at translation. In terms of whether large language models inherently favor English, I would say the answer is yes, because most of their training data is in English, and therefore like what they've learned is in English. However, because they're good at translation and because they're pretty good at doing things in English, you might imagine a scenario where you have a less common language. It's able to kind of inside, in its inner workings, translate into English, do whatever it needs to do in English, and then translate it back out into the other language. So I think that these large language models are kind of democratizing access to English writing. But you're right that especially with very low resource languages where there might not even be enough to have a good translation, there might run into a lot of issues.
There's a very interesting Johnson column just recently all about how ChatGPT's turned out to be very good at translating even into languages which you would not expect there to be huge amounts of training data out there for. And it's surprised people, it really has. And it does it with colloquialisms and everything. So it's really interesting that it raises the question of how much training data do you actually need for it to become really good. That we're running close to our end time now, so I've got a final question for all of you, and you really have to answer this one very quickly. Are you broadly optimistic, more pessimistic, or on the fence about this latest generation of AI and what it could mean for humanity? I kind of think I've got an answer from all of you, but Arjun, what do you think? Optimistic, pessimistic, on the fence? Quickly, why?
I'm optimistic, and I think it's because humans have historically always had these types of anxieties with new technologies. It's precisely because of that we come up with new solutions for how to adapt to them, make sure that we stay in control, make sure we're leveraging the advantages and minimizing the risks. So I think ultimately the optimistic. There will certainly be disruption over the short and medium term, though. Yeah.
Abby?
I'm still on the fence. I think it's going to be up to see how humans are able to use this tool, and how that ends up happening.
And Tom, optimistic, pessimistic, or on the fence?
I think I'm on the fence, but leaning towards optimistic. I think it's very interesting. If you look at the three sort of leading lights of the field who won the Turing Award a few years ago, Jeff Hinton, Yoshua Bengio, and Jan LeCun. Jeff Hinton, of course, resigned from Google last week because he's worried, so he's a pessimist about where this is going. Jan LeCun is a sort of super optimist. He says this is going to lead to a new renaissance. But as Arjun reminded us, experts in a field are in fact not the best people to ask about where things are going, whether they talk about likely positive or negative outcomes. So I'm with Yoshua Bengio, who's in the middle, who says this is a cool technology. It will have good uses. It will do great things, but obviously there will be problems along the way. And that was true of cars. It was true of planes. It's true of medicines, and I think it's going to be true of AI as well. So I think broadly in the direction of progress and a good thing, but that's not to say that there won't be problems that we need to deal with.
Thanks for watching. If you'd like to find out more about our upcoming events, please click the link. On the same page, you can also find recordings of previous events, including a look at Israel as it turns 75. See you next time.